Now, for example 3, we aren't given an angle measure, so we aren't going to know the value for theta, but we know that the terminal side lies on the line 8x plus 3y equals 0. And so if we can rewrite that to be in y-intercept, slope-intercept form, and so if I kind of move the x to the other side, I would get 3y equals negative 8x. Dividing by 3 gives us y equals negative 8/3 times x. And so thinking of what this angle should look like in standard position, I know it has a negative slope, and the y-intercept would have to be 0, so it passes through the origin, which makes sense because if the terminal side lies on it, it has to pass through the origin. And the slope of negative 8/3 means that if I move 3 units in the horizontal direction, the graph would be, the height would be 8 units in the vertical direction. So I think I counted those tick marks properly, and so we would end up with a terminal side somewhere on this line. But now there's a bit of a question, right? Because if I'm looking for sine of theta equals y over r, and this line that we're talking about, it passes through quadrant 2 and also quadrant 4. But if you think about y over r, the y value is going to be positive in quadrant 2 and negative in quadrant 4. And so certainly the sine ratio is not going to be the same for those two locations. So we need a little bit more information. And the problems that you deal with on homework or on quizzes or tests will add a little bit more information here. And in particular, you'll be given information about the quadrant. And so let's add that. Let's say that the quadrant is in quadrant 4. So that will have to be given within the problem. That's not something that you can determine from the original statement of the question here. So this will be included in problems like this. So if we know that we're working in quadrant 4, that means that the terminal side is actually going to be on this side of the line down in quadrant 4. And we don't know, again, we don't know exactly what the value of theta is. The smallest positive angle would be, something like this, so something a little bigger than 270 degrees, but smaller than 360 degrees. But we don't need to know that, because what I can do is think about, okay, I know what the slope of this line is. I know the slope of the line is negative 8/3. And so if I move 3 units in the x direction, I know that I'm going to drop down 8 units in the y direction. And so I can build a reference triangle and use that information to describe the side lengths of the triangle. I know that if the x value equals 3, the y value, the corresponding y value, would have to be negative 8. And so to find sine of theta, of course, we need to know r as well. And using the Pythagorean theorem, r would have to be, well, let's see, it would have to be the square root of 3 squared plus negative 8 squared. Negative 8, of course, is 64 if we square that, negative 8 squared, and 9, so I get the square root of 73. And so the answer to our question, the value that we're looking for, sine of theta, again, it's going to be y over r. Because we're in quadrant 4, the y value is negative, so I get negative 8 over the square root of 73. Rationalizing the denominator, which is kind of a nice thing to do, we get negative 8 times the square root of 73 over 73. But either of those would represent an exact answer. So you don't need to rationalize the denominator to get an exact answer, but it is kind of a nice thing to do. So let's take a look at number 4. If I know that the sine of beta is negative 7 over 13, I'd like to find the secant of beta. And this is similar to an earlier problem that we've seen, that if you know one trigonometric function value, you can from that find any of the others. There's a slight twist that we'll get to for this, but the idea is if I know that sine is -7 over 13, that will give me two side lengths of a reference triangle. But there is, as with our second example, as with example 3, there's a bit of an issue here. So let's think about when can sine of beta, for what sorts of angles can sine of beta be negative? Sine is y over r, and so it's going to be negative when the y values are negative. So it'll be negative in quadrant 3 and in quadrant 4. And so we could sort of envision reference triangles that have ratios of 13 over 7, of -7 over 13 in either of these places. So we could have a reference triangle that looks like this, or a reference triangle that looks like that, and either of those would work. So we need to kind of choose one or the other. So let's say, and this again would be something that would be stated in the problem initially, and I kind of included it to emphasize the point here, or I excluded it to emphasize the point. But we would need to know that beta is in quadrant, let's say it's in quadrant 3. So that will be included in homework and test or quiz problems that you might encounter. So if we are in quadrant 3, our terminal side is going to fall something like that, and we know from the given information that if I draw that reference triangle, I know the y value is going to have to be -7, and the value for r is going to be 13. And so we can use the Pythagorean theorem to figure out what the value for x should be. If I take 13 squared minus -7 squared, we get 169 minus 49. And so that value for x is going to be the square root of 120. Because the difference between those is 120. And with this example, 120 is actually divisible by a perfect square number, so we could simplify that a little bit. If we think of this as the square root of 4 times 30, since 4 is a perfect square, I can think of this as the square root of 4 times the square root of 30. And so this would be the same as 2 times the square root of 30, which is a slightly nicer number because the value under the square root becomes smaller in that way. So x equals 2 times the square root of 30, but we should think for a moment, should that value be positive or negative? Because the terminal side is in quadrant 3, we're to the left of the y-axis, and so the x values should be negative. So now that we've set up the reference triangle, we can finish the question. Secant of beta in general. Secant of beta is the r value over the x value. It's the inverse of cosine. And so I get 13 divided by 2 square roots of 30. Or we can think of that rationalizing the denominator. I'm sorry, that should be a -2 square roots of 30. Rationalizing the denominator, we can think of this as -13 square roots of 30 over, if I multiply the bottom by the square root of 30 as well, I get a 60. 2 times the square root of 30 squared. So let me end the video with a final question. From the examples that you've seen in here and the discussions from earlier videos, think about what the answer to this question should be. Suppose we know that the tangent of theta equals -8 over 9, and we also know that cosine of theta is negative. The cosine value is less than 0. So with that information, what can we say about the sine of theta? What would the value of sine theta have to be? Thanks for watching.